Welcome back. So today we're going over the introduction for exponents, and in this one we're going to talk about what we do with exponents and how to represent them in multiple ways. So with the information here, we're going to go ahead and start with this one right here where it says draw an array that represents a 5 by 5. Now an array is just a grouping, so if it's a 5 by 5 grouping, that means we're going to have 5 boxes by 5 boxes, which gives us a grand total of 25 boxes in this location. So when we look at that, if this 5 by 5, we could write this different ways, and that's why we start using exponents. And then thinking about that, if this represents a 5 by 5, what does this picture over here represent? Okay, moving on. Alright, so with this one we have bases and exponents as far as our vocabulary goes, and the bases here, for it to be a base, the base, it's a number that's being multiplied by itself. So in this example here we have 9 squared, and in that case 9 is the base, and then here we have 6 to the 4th power. That would be 6 as the base. As exponents, we can see they're determining the number of times that it's multiplied by itself. So in this one, 3 to the 5th power, we're saying that it's going to multiply that 3 by itself 5 separate times because 5 is the exponent. And this one, 2 to the 7th power, we know that 7 is the exponent, and that means that it's going to multiply that 2 7 times there. So that'd be 2 times 2 times 2, 7 of those. And then any number that's raised to the 2nd power is said to be squared. So we could call this one up here 9 to the 2nd power. That would be also 9 squared. Some examples of that, we have 3 to the 4th power. The base is 3, the exponent is 4. We have 7 to the 3rd power. The base is 7, and the exponent is 3. And then we have 9 to the 2nd power, or 9 squared. The base is 9, the exponent is 2. And then we have 8 to the 9th power, and that would be a base of 8, an exponent of 9. And then we have 12 to the 0 power, which the base would be here 12, and the exponent would be 0. Alright, completing this table, we have some information, and we're going to take that information and complete that based off of what we're missing. So if we want to know what the term is, we look at the base and the exponent, and the base is 5 and the exponent is 3. That means our term is going to be 5 to the 3rd power. Now if our term is 19 to the 2nd power, that means our base is going to be 19 and our exponent is going to be 2. The next one here has a base of 11 and an exponent of 4. That means I'm going to go ahead and have 11 to the 4th power as the term. The term 16 to the 4th power has a base of 16 and an exponent of 4. The term for the base of 7 and an exponent of 6 would be 7 to the 6th power. And the term for a base of 4 and an exponent of 11 would be 4 to the 11th power. Expanded form and standard form, those are two different ways that we write certain things, and it helps us understand some of the problems that we're working with. But expanded form, it shows the full multiplication of the bases. So if I were to write 6 to the 3rd power in expanded form, that would be 6 times 6 times 6. You'll notice that the 6 here, the base, there are 3 of them, and that's why the exponent is a 3. And then we could also write this one in expanded form, 3 to the 6th power, which means that we would then have 3 times 3 and have 6 of them, because that's what the exponent tells us there is. Now standard form, when we're writing in standard form, we're going to raise the power and then we're going to simplify it, and then we figure out that answer, and that's called standard form. So if we were to go to exponential form down here in this table, we have the exponential form because there's a 5 times 5 times 5. There's 3 of them, just like there was up here, and since there was 3 of them, that was 6 to the 3rd power. Well, the base here is 5, so this would be 5 to the 3rd power. And standard form, we would just take 5 and times it by 5 and times it by 5. So 5 times 5 is 25, times 5 is 125. The next one is already in standard form, so I have to think of two numbers that when multiplied together give me 36, and they have to be the same number. And so if I look at this, the two numbers that make 36 would be a 6 times 6, and going from expanded form to exponential form, there are two of them here, so the base is 6 and the exponent is 2. So that would be 6 to the second power, or 6 squared. 7 to the third power, that would be 7 times 7 times 7 in expanded form. And then if I multiply that through, 7 times 7 is 49, and then times 7 would give me 343. Our next example. 9 to the first power. Now that one kind of seems tricky, but all it is just saying that there's a base of 9 and an exponent of 1, which means there's just one 9, which means my answer is 9. If our expanded form is 2 times 2 times 2 times 2, there are 4 of them. That means I'm going to have 2 to the fourth power in exponential form. And then over here, if I multiply those 2's all the way across, I'm going to get 16 in standard form. Alright, in exponential form I have 4 to the third power. That means I'm going to have expanded 4 times 4 times 4. And then in standard form, 4 times 4 is 16 times 4 gives me 64. I have expanded form here, 3 times 3 times 3. I think I said enough, maybe one more 3. And in exponential form, that would be 3 to the fourth power. And then if I were to multiply this, 3 times 3 is 9, times 3 is 27, times 3 is going to be 81. Now I have 27. I can't think of any two numbers that give me 27, but if I followed this one up here, 3 times 3 was 9, times 3 was 27, which that gives me 27. So I know this is going to be 3 times 3 times 3. And in exponential form, that would be 3 to the third power. Now we have 2 to the fifth power. That would be 2 times 2 times 2 times 2 times 2 in expanded form. And then from expanded form, I would then multiply it through to get 32 in standard form. Now, exponential form, the next one I have 4 to the fourth power. That would be 4 4's multiplied together. And then in standard form, I multiply those 4's together to get 256. The next one is like the top one that we just barely did on this page here, 8 to the first power. That would be just 8 because there's only one of them, and that would be multiplied to give me just 8. Now these bottom two are meant to be tricky, and you can see here we have a 2 times 2 times 5 times 5. Now I can't have a base of just 25 because there's 2's and 5's, but I can put together the things that are similar. And notice this one is a 2 and that one's a 2, and there are 2 of them, so I could write that as 2 to the second power. And this one is a 5 and a 5, and there's only 2 of them, so I could write times 5 to the second power. And that would be in exponential form. And then I just go ahead and multiply through here. A quick trick, 2 times 5 is 10, so 2 times 5 is 10. 10 times 10 would be 100. The next one, we go ahead and see that there are 4 3's, so that would be 3 to the fourth power. And there are 2 6's, so that would be 6 to the second power. And we multiply them together in expanded form. Exponential form. And then from expanded form, I just multiply through 3 times 3 times 3 times 3 times 6 times 6. And I would get a grand total of 2,916. Alright, if you have any questions on this, let me know. Hopefully this was helpful for you today. Have a great day.